So thank you, and thank you for the invitation to speak here. It's really been a pleasure to listen to all of the talks so far today, and I'm sure the next panel is also going to be really interesting. So as Chris mentioned, I'm at the University of Nottingham at the Horizon Digital Economy Research Institute there, which is actually a multidisciplinary research institute. Part of my role there is actually to be a policy impact person for the institute. So that's one of the reasons why I've been doing a lot of that kind of work. And one of the reasons why I've been privileged to have the kind of support that enables to do this kind of work. So before I get off my track, so I'm going to be speaking about 4 projects briefly. One being the Unbiased project, which has morphed into the Reintrust project, which has been focusing very much on questions of bias and now trust relating to algorithmic decision making. Then I'll briefly talk about the IEEE standard for algorithmic bias considerations, as well as one of the policy works that I was working on last year and which Chris contributed to. And finally, I'll talk a bit about something that is very current in the policy space in the UK right now, which is age-appropriate design. But before going into the projects, I wanted to say a couple of words about the Horizon Digital Economy Research Institute. So this is a research institute that is part of a number of digital economy hubs that the UK government set up. This started about 8 years ago, and it's really about looking at digital technologies, how they are impacting on society. So digital economy, not purely in the economy as in increasing GDP or something like that sense, but in the wider sense of impact on the society. It's a center that includes also spokes, we're calling it, so branches out at the University of Cambridge, Newcastle, Exeter, and involvement with the Royal College of Art. But the main focus is at the University of Nottingham. And as you can see there in the word cloud, it covers quite a wide range of topics related to digital. But within Nottingham especially, a large focus is on privacy and ethics kinds of questions. And here on the side you see just a small number of some of the research projects that we've been doing, including the Reintrust one and the Unbiased one that I'm personally directly involved with, in addition to the general doing policy impact for the Institute. So Unbiased, as I mentioned, it's about bias in algorithmic systems, but it very much from the start, the decision was to make this a co-designed project with participants. And the focus, the group that we decided to focus on is 13 to 17-year-olds, because they are heavy users of digital technologies. They're assumed to be sort of digital natives because they know how to make the device work, but that's a completely different thing from knowing what the implications are of using the device or being able to control your interaction with them in a responsible kind of way. So the project, which was a collaboration with the University of Oxford and the University of Edinburgh, teams in both of those, consisted of 4 work streams, one of them being stakeholder engagement activities, referred to as youth juries with the 13 to 17-year-olds. A second part being development of some technical tools, piloting some potential ways in which to improve the way in which technology communicates with users. Then our partners in Oxford were looking at doing user observation kinds of studies. And the part that I was leading was a stakeholder engagement, so that's really focusing on engaging with industry, with civil society groups, and with regulators, and in this case also with educators as some of the key groups that relate to the way in which this technology is being developed, the way in which it's being regulated, and also the way in which information about how it works is being communicated and taught to students. So the youth groups, the youth jury's work has fed directly into the age-appropriate design code work that is currently ongoing and which I'll get to at the end of my talk, which is a new part of legislation that was passed in the UK in 2018 and is really about an obligation towards the designers of this kind of technology regarding how they interact with underage, so under 18 people. As Chris mentioned, one of the key pillars that we pursued as far as stakeholder engagement with industry is concerned has been through the standards work with the IEEE, but also responding to parliamentary inquiries, both within the UK and also doing some commissioned work for the European Parliament on a governance framework for algorithmic accountability and transparency, which is also a part I'll go into in more detail. And so the other part being the stakeholder engagement directly through workshops. So that was very much aimed at taking what we'd learned from the youth jury's engagement, bringing that to the stakeholder groups, hearing from them how they could consider to take on board what the young people had told us, what kinds of means they might see for actually implementing that or for taking that into the regulatory kind of space. And so some of the stakeholders for that involved a team at the European Commission who were looking at algorithmic awareness, as well as people from some industry, including the small and medium enterprises and some of the larger industry players, as well as various civil society groups, including Five Rights, where I'm also a trustee now, and which has been one of the driving forces behind age-appropriate design. And one of the outcomes of the whole project has actually been also the development of a educational tool, which I'll get into in a bit more detail now. So let me see if this video will work. So this is also one of the outcomes. The
internet is a vast ocean of information, containing facts, opinions, and cute cat gifs. There are billions of websites, so how do you find the ones you want? Algorithms help us do this. Algorithms are sequences of instructions that achieve a particular goal, like solving an equation, following a recipe, or finding a web page. When we browse online, algorithms find pages that match what we seek. They do this using the search terms we entered, as well as our search history, location, the time of day, and what other people are looking at. This guides us to music, shows, and articles that we are likely to engage with. So if you like carrot cake, green jumpers, or a particular political party, you will encounter similar stuff. But by diverting us from what we might find boring, tailored browsing can hide the bigger picture, stopping us roaming in the digital world of ideas. After all, it's useful to see other people's point of view. And perhaps you've looked great in red. And since we can't see how algorithms make decisions for us, it can be hard to appreciate how they affect our opinions. Just as we demand transparency when it comes to our food, we need more information about our individualized digital diets. The internet is an incredible resource for human connection, but what we encounter there ought to be balanced, healthy, and fair. This is the goal of the Unbiased Project. By asking a range of people about how they experience internet algorithms, we are establishing how to make these important tools easier to understand and more trustworthy. This research will encourage the individuals and companies tasked with regulating and designing the internet to think about users' concerns and act on them. So our future internet can become a place of free yet fair exploration for us all.
So as I mentioned, one of the outputs from the project has been an educational tool as well. And we decided to go with an analog tool for that, because one of the ways really is not to get people to just be reading something, but to engage with this and to do this in a group in order to stimulate discussion with each other. That way they can explore beyond what the tool itself has provided. So the tool is built around a deck of cards covering a number of different aspects that go into your engagement with algorithmic systems, such as what your rights are. Most people aren't really aware of what kind of rights they have, what kind of values go into these kinds of systems. A glossary of kind of terms, what kind of factors play a role within the way in which these systems interact with you, typically what different types of data that might be collected, under what kind of reasons, examples of use cases, some processes, and some exercises. Exercises such as try to imagine that you are the algorithm that has to do a certain kind of task. That way you have to think through the different kind of steps that might be involved, why it is that certain types of data are being collected in order to be able to actually do the kind of thing that this algorithm is supposed to do. If you are the algorithm that's going to guide you from this location to a different location in the city, what kind of information do you need to know in order to make the decision at each crossing point, whether you should turn left or right, those kinds of questions. And really to engage as a group with this kind of discussion. And so even though the Unbiased project finished in December and has now become the Reintrust project, we also got some follow-on funding to work further on this particular toolkit, which has allowed us to develop a facilitator booklet, which basically presents various kinds of games that you can do with these cards in order to help introduce how to use them, ultimately with the idea of making this something that can be done without us being present as facilitators, but rather teachers, for instance, in school classes can use it. Or, as I found out when I discussed this kind of thing at a summer school recently with people from the European Commission, you can use it to help the policymakers understand how these systems work. And actually, someone else in the House of Lords also told me that this would be very useful for her to tell to the other people in the House of Lords on this topic. So yes, it was designed with the help of 13 to 17-year-olds, but the user group is probably much broader than that. So moving on to the standards work. So this is part of a larger initiative that the IEEE is running. And it's basically comes from them looking at what their logo is, advancing technology for humanity, and saying, well, maybe we should do a little bit more work on focusing on that that it's not technology for the sake of technology, but rather technology to help humanity. And so as part of that, in end of 2016, the IEEE launched a global initiative on ethics of autonomous and intelligent systems, which consists of, on the one hand, developing a general kind of reference book on ethically aligned design, which covers various topics ranging from transparency to the use of algorithms in the legal domain to different kind of value systems and philosophy that might go into deciding what is fair or what is not fair, and those kinds of questions. But on the other hand, there's also a set of standards that are being developed. So there's currently 13 ongoing standards. The first of them is currently in the balloting process, which means hopefully in the run of this year it will become a published standard that can be used. Ours is P7003, so we're hoping to get towards sort of a first round of balloting, which is more towards getting external input into it. at the end of this year. It will probably take a little bit longer to get to the actual final kind of process. So that it will be, the typical time for a standard to develop is something like 3-ish years. And we're sort of on track for that. But as you can see from this list, it covers things ranging from the general model process for how to think about ethical concerns during system design to more specific ones such as transparency in autonomous systems, data privacy, bias considerations, down to even more specific things such as machine-readable personal privacy terms, those kinds of things. So on the algorithmic bias considerations, really what's at the core of this is the recognition that algorithmic systems are, by their nature, they're actually socio-technical systems, not just a technical system, because ultimately they are built by people who are part of organizations which are part of societies that have social, political, legal, and cultural contexts. So the outcomes of algorithmic decisions can have significant impacts on real and possibly vulnerable people. Therefore, we need to think not just of the technology side of things, but also the societal side of technology. So the algorithmic bias considerations, what do we mean when we're talking about bias in this context? What we mean is unintended, unjustified, or unacceptable within the context of use kinds of outcomes. Because if you were to take a very limited, a very mathematical point of view on what is bias, basically any kind of decision that isn't just a random one or always the same decision could be termed as bias, but that's not really what we're talking about. What we're talking about is unintended and unjustified, unacceptable kinds of issues. And so the causes for these kinds of bias, generally speaking, tend to relate to insufficient understanding of the context of use, failure to rigorously map the decision criteria that are actually being used both in the design and by the system as it is developed. And this is a space where machine learning can be very challenging. And failure to have explicit justifications for the chosen criteria. And then, of course, communicating those justifications to the community that's going to be affected and understanding whether they are acceptable kinds of justifications in this context. So just very briefly, various types of issues that go into causing these kinds of bias. One root is bias in the data. So generally speaking, we can say data tends to reflect the way in which society currently is or has been, but that frequently is not how we've decided that we want society to be. Our norms and values as a society change over time. We set our laws to be targeting at the way in which we want society to be, not necessarily the way it is. But if we just feed in historical data to drive the system, what we end up doing is re-entrench the injustices that we had in the past. Other kinds of causes of bias are the ways in which the optimization targets are chosen. And this is a very non-trivial problem because there is no such thing as being able to say that this is one way is always the right way to go. So this is really referring back to the machine bias example that Chris already mentioned. After the paper was published by ProPublica criticizing the way in which the system is currently working, various academic studies went into looking at what the actual problems are. Is there a way to build this kind of system that would be fair? And really, a core problem is there is no single "this is fair." you have to choose what it is that you want to be non-biased. Are you going to focus on false positives, or are you going to focus on overall misclassification rates? Are you going to focus on true positives? These things, you cannot make the system be fair or unbiased across all of these different kinds of measures simultaneously. And which of these is the one that you should be focusing on is a societal choice. So this is a point where companies that are building these kinds of systems need to engage society. There needs to be a dialogue to understand what it is that we should be choosing. And it needs to be transparent that this is the choice that was made, so that it can be challenged if necessary. And more generally, I could summarize it as saying the issue is that complex individuals are being reduced to simplistic binary stereotypes. And the example that I like to use for that is the misguided study that was done to try and use deep learning system to see whether your sexual orientation is represented in your facial features. And one of the things, just putting to one side whether or not the system even worked, that's basically irrelevant. The way it was set up to start with was a decision that people are either straight or gay, and that there is no such thing as anything in between. That is a decision that was made by the designers to begin with. The system was built to train and classify people into those kinds of binaries. Generally, I think we would say that is an incorrect assumption to start with. But it's the kind of, it's a exaggerated case probably of the kinds of simplifications that go into pretty much any time that you want to automate a system. So thinking then back to trying to develop a standard around algorithmic bias considerations, what are the kind of key questions that need to be posed when developing an algorithmic systems? You need to understand who will be affected, what the decision and optimization criteria are, how these criteria are justified, and whether this kind of justification is acceptable. And so this is a kind of brief overview of the types of processes that we're looking at within the standard. Basically, it consists of two parts. The first part is more of a understanding of the problem space, like a stakeholder analysis, risk and impact assessment. And then in the bottom is more sort of the technical perspective of looking at how the system's actually working. To what extent is the data that was used representative of the people who will be affected? To what extent, how is the outcome biased or not? Those kinds of questions. And really, the idea is for this to primarily be a process framework for the procedure to go through during development, how to document the decisions that are being made at all of these stages in order to be able to clarify what your justifications are. IEEE has also recently started a certification program for autonomous and intelligent systems. This is something that has started more recently and is ongoing. And so I'm going to have to very briefly go through. So last year, the European Parliament's research services asked me to do a study on potential governance framework for algorithmic accountability and transparency. And I was fortunate to have Chris join on this work together with other colleagues from a research group at EMLSRI, at University of Oxford, as well as the AI Now Institute. And so the 4 key areas that we covered in the outcomes was one thing being algorithmic awareness raising related to education, as well as support of whistleblowers and journalistic review, accountability in public sector use, such as in the procurement process, regulatory oversight and legal liability frameworks, and a need to look at global coordination around algorithmic governance. And then finally, age-appropriate design. So as I mentioned, this is something that was introduced last year in the Data Protection Act 2018 in the UK. It was strongly supported in the House of Lords by Baroness Kidron, who is also the founder of Five Rights. And what it really does is to focus on the fact that on the internet currently, it basically approaches everybody as being equal. However, if we look at even the Charter of Human Rights, and at the UN, we have a separate charter for the rights of children, recognizing the fact that children are actually a vulnerable group and should not be treated equal to adults. And within that, we need to be thinking not just of children as everybody below 18 being equal, but rather different age stages having different kinds of requirements of and ways in which they use the internet. And so this is now at the stage where the ICO, the Information Commissioner's Office, which is the data protection authority in the UK, has developed a code around how to implement age-appropriate design, which is going to be something that companies need to do. And this is currently at the stage of an open consultation. And thank you very much.
We'll do the panel for our last. I know this is the panel standing between you and the wine. Derek?
So this question is kind of for the first presentation, and it kind of relates to how we might define bias, and it may vary across disciplines. Because I think in my economic frame, we think of bias as some systematic error that's not random, that's included in the process. And, I see some of the statistical discrimination literature and some of the algorithms that could lead to bias somewhat related, where statistical discrimination that is not, that's based on correct notions of distributions may not be biased, but the problem is that a lot of times statistical discrimination is based on a perception that's biased. So we end up with notions that black people might be more inclined to do something based on, and then we apply a distribution. So it might be morally wrong to statistically discriminate, period, but it might not be a bias problem unless there's something systematic. And then I know it's a long question, I'll get to the question, but the main point that I'm trying to get at is a lot of our data input might be based on how we measure things incorrectly, or, for example, if police over-police black communities and are more likely to identify them as drug users. So you find more black drug users, but that doesn't mean that blacks are more drug users. So I guess I'm trying to get a question at you to distinguish between bias as being something that is based on inaccuracies versus bias in a way that other disciplines may define it.
Yeah, I think that actually brings up, as I had in kind of the presentation I was looking at, I looked at two things. One, kind of what was the success rate of a group and what was the accuracy of a group as two different measures which gave us a different view on things. As Dr. Koene was pointing out, just simple notions of false positive versus false negative versus accuracy that we can't simultaneously satisfy all of these what is the right measure for any given situation is dependent on that context. As Dr. Rourke was pointing out, we really need to understand the context of a decision, the individual group that's impacted, what those individuals feel is appropriate. You can't come up with a single statistical measure that's going to work for all cases. And so I think that's one of the real issues here, is that as computer scientists, we'd like something simple like that. We're not going to get it. We can prove we're not going to get it. And it means that we have a harder, deeper problem in understanding any of these, and a problem where we really need to engage the stakeholders, those who are impacted by these systems, in order to determine what are the measures that should be looked at for any given context. And so I think it's people looking at this, in a legislative or computer science want a simple, want a simple measure they can use. And that's one of the hard things, is there isn't a simple measure, that it keeps changing every time you look at a new problem. You have to figure out a new solution. And so that's part of coming up with such a standard is also part of the difficulty. Is in order to do this, we need to come up with not just here's the answer, but here's the process you use to find the answer that somebody's going to have to do every time.
Okay, thank you very much.